Hello everyone, welcome back to Coding Intuition. Today we are going to solve construct binary tree from in-order and post-order traversal question on LeetCode. So in this question we are given in-order and post-order traversal of a binary tree, and we need to construct a binary tree using that in-order and post-order. So to understand what is in-order, post-order and what is a binary tree, let us move to whiteboard. So here we are given a binary tree. And what is a binary tree? A binary tree basically a tree which has uh, at most two children. So it can have two or less than two children. So we are given a binary tree here, and we are not given a binary tree. We are given its in order and post order traversal. So what is an in-order traversal? In-order traversal is a traversal in which we first traverse left, then root, then right. So as we can see here, first of all we have traversed the leftmost element, which is 5. Then we have gone to 3. Then we have gone to its right. So basically in the subtree itself we are also doing the same thing. We are doing left, then root, then right. So we go left, root, right. We have completed this left. So we go to root. So we have printed the root. Then we go again to left, root, right. So that's how in order traversal works. And how is post order traversal works? So in post order traversal what we do is we basically go to left, then right, then root. So as we can see here, first of all we have gone to the left, then right, then root. So root comes at last. So similarly we will now not go to 2 first, we will go to its right first. So this is its right. So we will go to left again, which is 7, right, which is 8, and 4, which is the root. And at last we will print our this root. So basically that's how we form in order and post order traversals. But in this question we are not given a tree, we are just given this in order and post order, and we need to determine how do we make a tree from these in order and post order. So one thing that is very clear from here, one intuition we can make very clear from here, that the last node inside our post order traversal will always be our root node, because as we can see the how this procedure works, left, right, root. So root will always come at the last. So by using this intuition, let us try to come up with a solution. So now as we know that our root value will be 2, as we can see here our root is 2 because the last value inside our post order is 2, and we know left, right, root. So last value in post order will always be our root. So we have found our root. Now we need to find out what would be in the left part of this and what would be in the right part of this. So in order traversal we know that we traverse it from left, then root, then from right. So if we find out root inside our in-order traversal, we can say that whatever is before the 2 is our left sub is part of our left subtree, and whatever is after the root is part of our right subtree. Okay, and similarly in the post over traversal, now as we know from in-order traversal that this and at this index we find the root, and before this we have 3 elements. So we can say that from the post order traversal we know that first left values will come, then right values will come. So we can say that as we know there are 3 values in left subtree, so from the first 3 value inside our post order will be the part of the left subtree. And next, how many values are after this root in order? There are 3 values after the root, like we have 2 and there are 3 more values after the root, which is 2 inside the in order. So we will take 3 more values after this, after right, 7, 8 and 4, and we will exclude this 2. So basically we have this now. So we can say that uh, in our left subtree we will have either 5, 3 or 6, which is left part. From we got it from our in order traversal, and similarly from post order traversal. So now we know that these are left and the right parts of our subtree, but inside the code how we will calculate that, let us just look at that quickly. So whenever we know that the last element of our post order traversal will be our root element. Okay, so as soon as we find the last element inside our post or traversal, we will try to find it inside in order traversal, and we will note the index. We find our root in order traversal at index number 3. So we have noted our index here. So to divide the tree, to divide it in the two subparts in order traversal, what we will be doing is, in order, the first part will be from starting up till this index minus 1. So that we have done here, up till this index minus 1 will become 2. Okay, so these are 5, 3 and 6. That's how we will calculate inside the code. Okay, and how will we calculate for this? Up till this index plus 1, as simple as that. So we will move to 4. So that's how we will calculate this part. So the ending will remain same in this, the starting will remain same in this. But will change the ending part, which will be 1 before the root, and the starting part for this array would be 1 after the root. Okay, and how we will calculate it for post order? So inside the post order, what we can say, that from the our starting, we need to consider index number of element, basically 3 elements. So we will consider starting index of the post order plus 3 elements. Okay, and we will subtract minus 1 because it is an index, and we only need to consider first 3 elements. And then we will try to find out the starting point of this second array. The second starting point of this second array would be right at where we find out our index, where we find out a root in order. So it will start from this. After we have completed the left values, right after that we have to consider our right values. So our right values will be there, so right after the left values. So what we'll be doing, from starting index plus root index, in this case we'll note minus 1. uh, what are we trying to find out here? We are trying to find an ending index, which is this inside the left, and ending index of the left subarray. Now we are trying to find a starting index of the right subarray. So starting index of right subarray would be starting position plus root idx. And why we are subtracting this from here, starting index of in order traversal? We are subtracting starting index of in order traversal. In this case it is simply 0, but as we move forward, we can see starting index of in order traversal will change. So basically we are moving this elements extra ahead, and we have to come this much back. That's why we are subtracting this from here. So that is basically we will be doing again and again until we find our complete tree. So let us just move to next stage in this. So here, as we can see, we will again do the same thing. Last element is 3, which is our root now again. So we have assigned root here, and in this array last element in post order is 4. So we found out another root element. So now we have these roots, and we will again do the same thing. We will divide it into 2. So the 5 will be the left part of this, or 6 will be the right part of this, and similarly in the post order traversal as we have done before. So we again divided the array, and finally we have found out our complete tree. So that's how we will run a recursive code and do whatever we have done in the first step again and again, to divide the array into subparts, and every time find out a new root and a new left and right for each root. So I hope that makes intuition algorithm very clear. Now let us just quickly jump to the code and understand this question completely. So now let's just quickly understand the code now. So in this code, as we can see, first of all, we are finding out the size of the array. The size of both our array will be same, as they are same number of elements in the tree. So there's a total number of elements in the tree we have calculated. Now we'll call a recursive function to get our tree. So we will pass in order traversal and post order traversal with the starting and the ending index of the traversal, as we have seen in the example. We need that. So we have sent the setting and then ending index of these arrays inside our recursive code. So first of all, we'll check if the starting index of our in-order traversal exceeds the end of in-order traversal, and similarly with the post-order traversal, we will return null, saying that it has exceeded uh, the bounds of the array simply. And first of all, we will find out our root. As we know, the last element inside the post order traversal will be our root always. So we have found out our root. Then as we have seen on whiteboard, we will find out this value, whatever is the last value inside the post order traversal inside our in order traversal. So we are trying to find out the index of that value. As soon as we find out the index or index of that in order traversal value, we will say whatever is before this inside the in order is our left. So what is our left? Our left is equal to whatever is before that. And for post order traversal, the first current the first element, the how many elements there are inside the in order traversal, that many elements inside the post order traversal we will consider. And similarly, the what will be our right, whatever is inside our in order traversal after the root is our right. And similarly, how many elements are there in order traversal after the root, uh, those much elements will taken our post order traversal. And here one more point to notice that we have done end minus one, which basically means our last element was root and we have excluded that. Now that is our not will not be the part of our coming tree, the last element. Okay, so that's how we will run this recursive function again and again, and we will find our answer. And this question will run an off n square time, because you are every time you are it will take n time an n time to find out the element inside the in order traversal, and running it again and again for all of the rule of finding all of the elements inside the tree, making a complete tree which is of size, let us say, have n nodes. So it will run these this one will run inside this n loop. So it will basically make it n square time. So in your interviewer might ask you to reduce this time complexity. You can do it by just using one extra space, by using an map. So and inside another map it will take of one time to find any value. Basically you will assign the value of in order traversal to keys and index to values. So you can find the index where you find the root value in O of one time, and that will reduce the time complexity to O of one. That simple modification you can also do inside your code. So I hope that makes the code and intuition very clear. So I hope you like this video. Thank you so much for watching. Bye bye.